Okay, suggestions for ones to talk about. Okay, I heard 44. I heard 35. 30? Other suggestions? 45? Yeah, we definitely want to talk about these two. All right, so is there two others from the previous ones we want to talk about? Other suggestions from 24 through 40? 30 and 35, are those the ones to do?
Yeah.
Was that one of the, good, okay, good. All right, so let's hand it in. Okay, so 30. So this is what we've been working on for the last couple days. So give a circle I can draw. Okay, that's okay. All right. What's the radius? 8 meters. So first he's going to go 38 meters, and he puts them, it's showing somewhere down here, right?
Yeah.
So 38, the red is the path of the car, 38 meters, and we want the x and y in meters. So we want the x and y coordinates of that point, right? And that would be for the origin being here. So x-axis and y-axis intersect, so the origin's at the center of the circle. Okay, yeah, so this is what we've been working on, right? How do we get x and y coordinates on a circle? Cosine and sine. And what's the input into cosine and sine? What do we need to radians or theta? Okay, so the x is going to be, it's going to be a cosine of something. And y is going to be sine of something. So it's going to be the cosine of what? So what does cosine receive as a function? What is the input?
38 divided by 8.
In general.
Radius length.
Okay? Yeah, radians. And we know that radians come from, radians are the same as, or the number of radians. Radians will be, I don't know if this angle is right, but radians is the measure of the angle. Okay, we ready to start? Everyone ready to start? Okay, so radians is the measure of the angle, and that value is the same as what? Is it 38?
38.
It's the same as what in general? The value of radians.
Radius length.
Radius lengths around the circle. Okay? We've said this a million times. And that's the basis of radians, is it's the angle whose rays cut off that number of radius lengths. That's what a radian is. So, how many radius lengths is 38 meters? So, yeah, you're going to take 38 over 8, because that will give you how many radius lengths you went around. And then the cosine of that will give you the x-coordinate as what kind of unit? So what will the output of cosine of 38 over 8 be?
Radius lengths.
In radius lengths. So it'll be a number between -1. So the lowest number of radius lengths to the left we could be is -1. The greatest number of radius lengths to the right we could be is 1. So normally, this is like what fraction of a radius length we are to the left or right of the vertical diameter. Okay? Similarly, sine will give us the y-coordinate, or the vertical distance in radius lengths.
We want it in meters.
And so, does it say meters or in terms of sine and cosine? Then determine decimal approximation. So, in meters. So, if this is radius lengths, how do we get meters? Yeah, so we can take the fraction that this is of a radius length, and one radius length is 8 meters. So this will be the number of meters that you'll get, because it's 8 times the fraction of one radius length. You guys ready to start? You guys, are you ready? Okay. It's just distracting the people around you. Okay. So this then is the fraction of a radius length above or below the horizontal diameter. And so if we multiply that by 8, we'll get the meter, the equivalent in meters. Okay, so let's see if, did I land in the right, is it in the third quadrant or fourth quadrant? Is it fourth? Okay, so x is positive, what is it? How many meters? 0.3 meters. So really, it should have been here. Should have been the fourth quadrant. So we're really right about there. Okay? Is that right? 0.3 meters? Okay, and then what do we expect for the y-coordinate? Positive or negative? Small or close to 8? Close to 8, right? Because it's almost to the bottom. So negative 7.99 meters. Okay, so we've done this lots of times. Hopefully it's starting to stick, and this is really important. Really important. Given the distance around the circle, can then we pinpoint the x and y coordinates on the circle? X coordinates cosine. It receives radians. We'll output radius lengths, and then so to get meters, we multiply by the radius. What is the measure of the angle in radians formed by the rays connecting 0, 0 and 0, 0 to xy? So what is the angle measure in radians? They're saying this angle measure right here. What angle measure is that in radians? In radians, so this angle. What is it? Yeah, that's the 38 over 8. That's the 38 over 8. That was the input into our cosine and sine in order to get the x and y coordinate. Okay, so now it says define a formula that rates the horizontal component x in radii in terms of the number of meters d that the race car has traveled along the track. So now instead of 38, how far does the race car go? D meters. So how do we get the so suppose D is here. How do we get the x coordinate of the point after the car goes d meters? Same thing. The cosine of d over 8. D over 8 then is how many radians it went. The cosine gives you the x coordinate. And then we're going to multiply by 8?
No.
It wants it in radii.
Oh, in radii. So no.
That's it. Which tutor center could they not do this in? Oh my goodness. Okay, next, part 2. Vertical component in radii.
It's just the sine.
The sine of?
D over 8.
So, the angle is the distance, the arc length, divided by 8 gives the number of radius lengths, which is the number of radians, which is the input to sine, and sine outputs the y-coordinate in radius lengths. Okay, the horizontal component in terms of the number of meters. So this is 1, this is 2. So now how would we get this x value in terms of meters? You're going to take, this is going to be the fraction, so suppose it's d takes us to right there. Cosine of d over 8 will be this value right here. This is cosine of d over 8, which will be a number like negative 0.8, okay, or negative 0.9. So we want then to get the number of meters that is, well, this is 8 meters from here to here. This is 8 meters right there. So we want whatever that value is times 8 will give us how many meters it is. And then the y-coordinate in meters. Is that right? Okay, so this is, hopefully it's sticking now. This is what we did the last 2 class periods. We did this the last 2 class periods. So they're really important. Anybody have a question? It's one thing to watch me do it and be like, oh yeah, I get it. But can you do it? So if you had a whole new situation and a whole new worded question was worded differently, would you have the confidence to write this down? Because this is important. Yeah. Oh, you think so? Okay. Okay. What was next? 35. Can I erase this? Okay, 35. What's the value of theta? So it would be nice to be able to go to the book. Let's see if I can find it here fast. Isn't that special? Well, using the other software. I didn't design that, but when I did the other stuff in the last week, yeah. Okay, homework student. Number 35. This. So I should have known the other one too. Okay, so we want the angle theta. What do we know about the circle? Do I have the right problem?
Yeah.
Okay, what do we know about the circle? You know the radius is 5. Okay, so what else would, if we want to know this angle theta, and we know the radius is 5, what else would we need to be able to?
The arc length.
Yeah, so what is the arc length? 26.17, right?
And that's just from 4.827.
Yeah, so from this point here to this point here, that arc length is the 26.17. What does the value of theta represent? So it's the number of radians, that's this angle, but it's also something else, that number. What is it? This is the key to answering the question, is knowing what else, what other number, the number theta, the value of theta, what else it represents besides that angle.
Arc length divided by the radius.
What does it represent? You all thinking it?
Arc length divided by the radius.
But what quantity does it represent? That's a formula. Radians isn't a measure of an angle, right? So besides the measure of an angle in radians, what else does that value represent? Radius lengths. Radians and radius lengths is the same thing. So you got to think interchangeably about theta. Think interchangeably. Whenever you see an angle, think, okay, that's the openness of the rays in radians, but it's also how many radius lengths. So that needs to come quick. Here, it's very convenient to think about this as radius lengths because we got 26.17 kilometers. We know our radius is 5 kilometers, so we're just asking how many radius lengths is 26.17. How would you find it? Yeah, you would just take the total arc and say, I'm going to chop it up into pieces of length 5, and that will tell me how many pieces I have, or how many radius lengths, how many of those go into that. So it's 5 point what?
2, 3, 5. 2, 3, 4.
Okay, so 2, 3. So, radians. Okay, what's the next question? What does 1.3028 divided by 5 represent? Oh, that's a good question. So how about the number 1.3028? What's that?
Vertical distance.
It's the vertical distance, right?
Kilometers above the horizontal diameter.
So that's the question. Is it kilometers or is it radius lengths?
Kilometers.
1.3028. It has to be one of the two. Which one? Has to be kilometers. Why?
Because radians is measured only up to 1.
Yeah, how many radius lengths is it to here?
1.
That's 1. You can't go any further than 1 radius length above in turn when you're talking about vertical distance. So if this way down here is 1.3, it's got to be in whatever units the radius is in. So this has to be kilometers. So what would 1.3028 over 5 represent?
The distance in radius lengths above the horizontal.
It'd be the same distance, but now measured in radius lengths. You see? You'd be taking that number of kilometers. If you divided it by 1 radius, you would have how many radius lengths you were above. Because this is 5 right here, right? So from here to here is 5. So you're saying 1.3 over 5 is what fraction of 5 is that? In other words, what part of a radius length is that? All right, what about 4.8273 over 5? First of all, what's 4.8273?
Horizontal distance.
It's the horizontal distance in
To the right.
kilometers, right? It's almost 5, 4.8 something, almost 5. So if we divide that by 5, we're getting the fraction that is of 5, which would be now measuring it in
Radius lengths.
radius lengths. So it's something like whatever that is, 0.96. 0.96 would be what fraction of a radius length you are to the left of the vertical diameter.
To the right.
To the right, thank you, to the right. So, does it make sense? Any questions on 30? It was just A through C, right?
How would you find measure A? Are we going to have to do that?
No, it wasn't assigned. Later, we'll do it later. Okay. Next, 44. Okay, 0.33 radians per second as she rotates on the Ferris wheel. Okay, so how many radians theta does Hope sweep out in t seconds? So I recommend, like we did in class, to make a chart. What does this mean, 0.33 radians per second? Can you explain what that value means, 0.33 radians per second?
Every second she moves.
Yeah. Every second.
3 of the radius length.
She said, yeah. So she rotates 0.33 radians. So after 1 second, how far will the Ferris wheel have rotated at 1 second? 0.33. After 2 seconds, how far will it have rotated? 0.66. After 10 seconds, how far will it have rotated? 0.99.
Oh, 10.
After 10 seconds. Every second, what does the Ferris wheel do?
3.3
it goes 0.33. So in 10 seconds, it will have rotated 3.3. How about in t seconds? In t seconds,
0.33 times t.
0.33 t. So theta equals 0.33 t. If we're going to introduce sine and cosine in this problem, or sine or cosine, what is the input into sine or cosine? What's the input? Theta. So we could, since theta is 0.33 t, and if you wanted to write a vertical or horizontal distance on the circle in terms of t, then there's your value of theta that you could plug into sine or cosine. Right? The argument for sine or cosine is angle. We've just written the angle in terms of t. So let's see what it wants us to do. It wants to define us a function j that relates her horizontal distance to the right of the vertical diameter as a function of t. So we want horizontal position, and I think they meant in feet.
Oh yeah.
Yeah. So oh, they never give the radius? Oh, so they didn't give the radius, then you could write it in radius lengths. Okay? So in radius lengths. So what would j of t be? We want the horizontal distance to the right of the vertical diameter. What would we use? That'd be cosine. Input into cosine? Right, because the input in the cosine has to be theta. Okay? So theta, we know in terms of t, is 0.33 t. Without knowing the radius, we can just stop right there, and the output of our function will be in radius lengths, like 0.6 or negative 0.4 or 0.2, right? It'll tell us what fraction of the radius she is to the left or right of the vertical diameter. Okay? Over what time interval does the Ferris wheel complete one revolution? So what we're saying is that the 0.33 t for one revolution would have to be, right, this is angle, and so that angle would have to be 2 pi. Really, this is key right here. So what value of t would give us an angle of 2 pi? That's what we're saying here. What value of t would get us to an angle of 2 pi? $19.04? Is that, what are we, in minutes, seconds? Seconds. Okay, so that was C. That's part C. Okay, sketch the graph of the function j and mark the interval of input values on which the function completes one full cycle. Okay, good exercise. Let's do that. I got some room here. So this is the function that we're graphing, right? And we know that it takes 19.04. Let's do that in terms of pi. So that would be really dividing by 1/3. So is this 6 pi? Is that what this is about? 6 pi. Because we're dividing by 1/3, which is multiplying by 3. Okay? So this t is 6 pi. Okay, so we got cosine 0.33 t and 6 pi. So let's just do so we want to sketch cosine of 0.33 t, and we know that It will one rotation takes 6 pi seconds. That's what we just determined. Okay, so how about just if we were graphing cosine? So just cosine theta. So we all should be able to just sketch that. What does that, what's the input and output of y equals cosine theta? So what's the input? What does it mean?
What it receives. So
And what does it receive? What does cosine receive?
the
Angle swept counterclockwise from the 3 o'clock position, right? In radians. Output is? Of what? What radius lengths? X coordinate or which distance? Horizontal distance from the vertical diameter. So at 0 radians, what's our horizontal distance from the vertical diameter? At 0 radians? 1, right? Okay. And then at pi over 2, at the top of the circle, what's the horizontal distance? 0. It's about 1.57 radians. Okay. At pi radians, what's our horizontal distance?
it's
-1. Remember forming this graph a couple periods ago with a bug on the fan? At the bottom of the circle, 3 pi over 2.
0.
Back to 0, right? The horizontal distance is 0, and then at 2 pi, back to 1 again. And it's just a straight line, right? Straight line down, straight line up.
It's a curve.
No, we talked about how we get that curve, right? With changes, looking at changes. Okay, so this is our generally, oops, like that. Okay, this is our cosine curve. But now we have this. And one rotation takes 6 pi seconds. And 6 pi was, again, 19.4. 04.
19.04 what?
Seconds.
Seconds. Okay.
So we'd have to redefine what our axis was. This would be what in seconds? So this in theta, it's 2 pi. But in seconds, it's what? Yeah, 19.04 or 6 pi, right? Okay, so halfway in theta, Aaron, the angle theta is pi. What is it for t? 3 pi. Okay, what is it 1/4 of the way? What's the value, what's the time 1/4 of the way then? At what time t? 1.5 pi. So it's going to be this half of this, 3 pi over 2. Okay? And then 3/4 of the way around. How much time to get 3/4 of the way around? If it's from 3 pi is halfway around, 6 pi is all the way around, it would be 4.5 pi, right? Okay? So now if we have the axis being time, then to take one, we found one rotation would be 6 pi seconds. So this input would have to be 6 pi, 4.5, 3 pi, 3 pi over 2. All right, so there's kind of two ways to do this. Here's the first way, is we can take the axis and take the same curve and change the axis. That's what I'm doing here. For the exact same curve, I'm saying here theta would be 2 pi, but t would be 6 pi. The other way to do that would be let the values be the same. So now, what will this graph look like if I actually have t and theta being these values here? So theta is correct, but what will the graph look like if now this scale is also the t scale? what will happen to the curve? What will it do? How will the curve be different? How will it be transformed to show the time, the cosine in terms of the time now?
Well, 19.04 would then
Yeah,
become your
this will be 19.04, right? So what would I have to do to this blue graph? Stretch it which way? Stretch it up. Stretch it this way. So the end of the rotation, oops, didn't mean to do that. The end of the rotation, this has to be 19.04 or 6 pi. Yeah, so the whole thing is going to be stretched out. So let me graph it, and we'll see that. So it's going to be the same curve, but it's going to be stretched out so that it ends at 6 pi, or ends at 19.04. So cosine of 0.33t, right? Oh, x. So where's this thing going to end? Oh, come back. So where did it complete one full rotation? Right there, at around 19.04. It completes the full rotation. So if we graph them both on the same axis, y equals cosine theta. So in terms of theta, cosine theta will always complete the cycle at 2 pi. But now we've got,
So one full rotation on the red graph is at the peak of right where.
so this represents the full rotation in radians, talking about input of radians. But now if it's input of time for that Ferris wheel, one full rotation doesn't occur until 19.04, about here. Okay, so this is, we're starting to talk about transforming graphs. Okay, so transforming, what happened when we multiplied by a fraction here? It ended up stretching the graph out, right? Stretching the graph out times 3, actually. Okay, but we'll talk more about that. Let's look at 45. Okay, same kind of deal. But now it's given that it takes 75 seconds. And does it give, this one give the radius? Still no radius. But it takes 75 seconds. That's all we need to know. Okay, so this is one of those great big giant Ferris wheel, right? It takes a long time to get all the way around. It goes real slow because it's more about a view than a exciting ride. So 75 seconds for one full rotation. And what are we going to, we want vertical distance or horizontal distance? So that's which function? That's sine. So what this will look like is, we've seen that this is what these look like. The argument into our sine and cosine is theta. Okay? But it's going to be some constant multiple times t is going to be our theta. So theta, so all we need to do is to determine that number, b, which I'm calling b, the coefficient of t. And we have information. We know that when t is 75 seconds, what, we make one full rotation. Okay, so what is the value of b? 2 pi. Yeah. And so think about it. So if it takes 75 seconds to go 2 pi radians, really what we're asking is how many seconds does it take to go, or how many radians do you go in 1 second? So you're going to take that and divide it up into 75 seconds. So what do you get for that? We're just going to actually leave it like that. So we have an exact value. So, but if we want to know, what is this? This is the number of radians that it will go in 1 second. So you said is what? 0.0? Radians per second. Because if it goes 2 pi radians in 75 seconds, then we're going to chop that 2 pi up into single seconds. We're going to divide it by 75, and that'll tell us how many radians it goes each second. Okay? And so then we want the sine of that number of radians per second times t. And what function do they want to call it? M as in Mary? M of t? What else do they ask for? Graph. Okay? So if we're going to graph this, if this axis is t, first of all, this is sine. This is the sine, so it's the vertical distance. At t equals 0, what's the vertical distance above the horizontal diameter? At t equals 0, it's
0.
Right? Remember, our sine curve starts at 0. Okay? And then, so now, how long is it going to take? And so then, what does the sine curve do? It goes up, right? To the top of the, when it's at the top of the circle, and then back down to the center line of the circle. Then it goes 1 radius length below, and then back like this. Okay, so that's sine theta. Turn these other ones off. So what will the graph in terms of time look like for this problem for the Ferris wheel if it takes 75 seconds to make 1 full rotation? Stretch all the way so that this pattern finishes when? At 75 seconds. So if we were to graph this, it would do the same pattern, but it would take all of 75 seconds to get back to this starting point, which is called 1 cycle. Okay, so this is 1 cycle. Do it in red, okay? That's called 1 cycle because it would keep repeating itself, okay? And so then we have what's called the period. Okay? The period then is the time or the interval of angle or the interval of time to complete 1 cycle. The interval of the input variable to complete 1 full cycle of output values. So what is the period of sine of theta? What's the period of sine theta? So what's the interval of input, in this case just theta, that gives us 1 full cycle? No, just sine theta. Just sine theta. So what interval of theta gives us a full cycle? 2 pi, right? What's in this function? What is the period? 75. 75 seconds it takes for the sine to show 1 full period. Sorry, 1 full cycle. Okay, anybody have a question? So I kind of transitioned into some new ideas here, okay? What we're going to be doing is looking at how we can now transform the original sine and cosine graphs that we created using the bug on the fan. So let's look at another example. Can I erase everything on the screen? Are we good on homework? Let's see how this goes. So an upright fan is rotating. The function related to this fan is 28 cosine 3t. I want you to describe the meanings of all these quantities. T, 3t, cosine 3t, 28, 28 cosine 3t. So in the context of all the stuff we're talking about, you can make meanings out of all 5 of those quantities. So I want you to do that. What are the meanings of those 5 quantities? Okay? What's the input of the function, the output? What's the period of the function? Explain the meaning. So let's see how this goes. Should be able to know what all those quantities mean. Yeah, so talk it out with somebody. Compare what you're doing. Okay, 1 more minute and then we'll go over it. So you not only should be confident, but should be able to articulate all the details of it, okay? So the details, specifically what each of those quantities is. Okay, what did you think T was? Time in seconds. What time in seconds? Since when? Since time in seconds, since a point on the fan was at the 3 o'clock position. Three t. What does that quantity represent? 3t. What's that? Is it a number of seconds? What do you think? What is it? What's it? Position measured in what? Yeah, so this is 3t is the input into cosine, which has to be what? Either radians or radius lengths. So this is the angle or the number of radius lengths. So we just say the angle in radians that the fan rotates from the 3 o'clock position. This is a key thing to see that whatever as a quantity, whatever's being inputted into cosine, that's angle. Does it make sense? So you got to recognize that. So that expression 3t has to be an angle or a number of radius lengths. Okay? Cosine of 3t.
The horizontal distance.
Horizontal distance.
To the
Right of
vertical diameter.
vertical diameter of the point in radius lengths, or radii, radius lengths, yeah. So it's going to be a fraction. It'll be a fraction of a radius length, right? Like the cosine gives us values like 0.75, 0.82. It's a fraction of the radius length that the point is to the right or left, vertical diameter. 28. Radius of the fan in inches. All right, 28, cosine 3t.
Horizontal distance to the right of vertical diameter.
Same thing as this,
In inches.
but now in inches because we're multiplying by the radius. Okay, what's the input of the function?
Theta.
What's the input of the function f? Time. Time is the input. 3t is the argument, but time is the input. Time is the input in seconds. What's the output? This thing in inches, right? It's the this is the output, this thing we just described. That's the output. Okay, what's the period? So the period is when the angle is going to be equal to, yeah, so this is how you find the period. You're going to say what time would make the angle 2 pi, one rotation, you see? Because this is angle. So what time, unknown, would make our angle 2 pi? So what will it be? 2 pi over 3 seconds will be the time for one full rotation. So where the sine is this, so where's 2 pi over 3? 2 pi over 3 is like here. So it's going to make, according to time, it'll have to do a full rotation in 2 pi over 3 seconds. That's supposed to be pointing. It should be the same height and length. Okay, have a great Thanksgiving. Yeah, sure. We will have normal homework due the Wednesday you come back.
Oh, yeah.
Yeah. Wednesday. Normal. Wednesday.
You better be, if you, well, I'm sorry. Well, I'll text you. If you want to go outside, get your work and your luggage and your little whatever going on, I'm going to go work.
You're walking. No, hold it back.
You will hold me back.
wanted the anchor.
Jeez. I see how it is.
Yeah. Well, I'm not gonna. You weren't doing it. Have a good Thanksgiving.
Good? I'm just